My name's Philip Smith. I work for Cisco. I do a few of these. I've done quite a few of these tutorials for NANOG, a series of 3 that I worked through, Introduction to BGP, BGP multi-homing, and this one all about troubleshooting BGP. I do these in quite a few different venues around the world. There always seems to be a fairly significant demand for knowledge about what the latest and greatest in BGP is, as well as just the simple tricks and techniques and so forth. So this topic gets quite a large demand from many parts of the world. Before I really get going, presentation slides, they're on the NANOG website, at least I hope they are there by now. They'll be at that URL, I hope. Failing that, you can get them from, well, the FTP site that I've listed there also. Also on that site, I've put a load of other presentations that I've done in the recent past, so if there are other things that you're looking for, whether it's BGP related or the general internet routing table and so forth, feel free to help yourself. All these presentations are publicly available. If you want to use them for your own internal training, your staff training, whatever, you're more than welcome to do so. I'm going to make some assumptions here. I've put this up on the NANOG site as being an introductory, intermediate level tutorial. I do make some assumptions that you do know a little bit about BGP. In other words, you have some working knowledge. So if you have no idea what it is, you're probably going to get really, really lost. But if you've used BGP on your own routers, your own network, or in a lab or something like that, then this is probably fine for you. I get many questions about, well, why don't you do an advanced BGP troubleshooting tutorial? And I think the answer really to that is, well, give me the content, I'll give you a really advanced troubleshooting. The problem is advanced troubleshooting is almost down to the peculiarities of the network concerned. And I'd love to do one, but it's getting actual content that I can present here that's not going to violate some kind of trust between me and the people who've been asking some of the questions. So this is really why what I've tried to do in these 180 minutes is try and look at some of the common reasons for why things go wrong in the networks, look at some of the common reasons or common calls that I get, emails that I get. A lot of these are also culled from inside my employer, just basically what they see or frequently asked questions and so forth. So to try and really cover the simple and maybe the not so simple but frequently experienced problems. Because I reckon if you can handle all these that are presented here, then you can pretty much handle any situation you're going to find on the internet today. Well, at least that's my theory. And it seems to be pretty much working so far. But as well, really what we've said in previous NANOGs and have said in this one, if you've got any good input, if you'd like to present this tutorial rather than me presenting this tutorial, please feel free to put in a proposal to the program committee, because they'll be delighted to have different faces behind the podiums from time to time. If you're afraid to speak, give me the content and I'm happy to be the talking head. It would be really nice to get different operational input for these presentations rather than just what I glean in my travels around the world. I also assume that you've got knowledge of the Cisco command line interface. Well, I work for Cisco. It's all I've ever used in my 15 plus years in industry. So that's just what I use in the examples. Hopefully you can translate the concepts into your own favorite router vendor. The ideas are all generally much the same, even though CLI may be slightly different. If you want to ask questions, there's a microphone provided in the middle of the floor. Rather than just shouting out from the middle of the room, if you'd rather come up to the mic anytime you want to ask a question. I don't mind when you ask, you don't have to wait for the breaks. If you want to ask a question, let me know. Come up, use the mic, state your name, whatever, and ask away. What I'm going to cover, well, those three topics really. Just have a brief walk through some of the fundamentals about troubleshooting, and then we'll have a look at local configuration problems, which will take the rest of the 90 minutes of the first part, and then second half we'll finish off the configuration issues and have a look at internet reachability problems. Because a lot of BGP troubleshooting isn't just, well, what's gone on the router, it's what's actually going on between me, the rest of the network, and out there, and what can I do? As you probably know, or at least some of you have probably experienced, if you have peering relationship with other ISPs, you get your customer saying, oh, I can't reach such and such a site. A simple brush off saying, oh, well, internet's broken or it's such and such a fault is not really a good way to do it. You need to know where to start to try and troubleshoot where the actual issue is. So the second half is going to cover some of those steps. So really, first thing you would need to try and do is have a look and see what's causing the problems for you. So some of the problem areas could be misconfiguration. Misconfiguration can be caused by bad documentation. Could be a co-worker who's written some documentation how something works and he's gone off on his holidays for 2 to 3 weeks and you're it. And well, there's an issue, you don't know what it is, you read his documentation, you dig in, try and change something, and it just makes matters worse. So it could be caused also by misunderstanding of the concepts. You've been to some of the tutorials or you've read your favorite vendor's documentation how BGP works, and well, it's not quite working how you think it works. Poor communication between colleagues and departments. That happens so often. From my days when I used to work at Unet, we saw that a lot. What the NOC would say is something is not working right. Customer would phone in, of course, saying can't do such and such. It would be translated into something else by the guy in the NOC who's just there just to make sure the router works or the network works. Translated into something else by second level support, and by the time it reached me it was like something that didn't make any sense whatsoever. What else can you get? You can get human error, for example typos, simple typing mistakes in the router configuration, use the wrong commands, just plain old accidents, they happen all the time. Poorly planned maintenance activities, that's a big cause of problems as well. Yes, you can sort of document what you're going to do for your entire maintenance, you think you've got every single step, but you've missed out one particular gotcha that just, well, ruins your whole maintenance effort that you're carrying out. That can be a big cause of problems also. More problem areas. Feature behavior, I put it in brackets because, well, it's just the usual thing that ISPs laugh about with the router vendors. Well, you know, something in release X.Y did this, but X.Y brackets B does something completely different, and oh, they've introduced a bug. Or it could be that something's working slightly different or whatever. Okay, so feature behavior is a fairly big issue as well. You find many of the bigger ISPs these days spend a lot of time certifying any image before they deploy it on the network. It's not a case of, ooh, Cisco or Juniper or whoever have just released a new bit of software, let's go and deploy it on the backbone. My time, my days in the 90s, that's what people did. It's like, oh yeah, we'll try this, let's see what happens. Oh, it's broken. Oh, okay, well, let's backtrack. You can't really do that sort of thing today. Interoperability issues. Well, you know, RFC 1771 was written a long, long time ago, and then we had the internet. Hopefully with the new BGP RFC that came out a few weeks ago, or finally came out a few weeks ago, that sort of thing should become a bit of the past, maybe in a year or so. But the differences in interpretation of RFC 1771 led to interesting situations, and I'll have a look at some of those a bit later on as well. And the problems caused by, well, situations beyond your control. Probably see less of it here in North America, but hey, we see a lot of it in Asia, where ISPs are trying to do the traffic engineering, and while their upstream ISP goes and changes the routing policy. An upstream ISP doesn't think about it because they're trying to do traffic engineering, but it completely blows what this ISP is trying to do. So they've got to go and reinvent everything, don't understand why the customers are complaining. Something that they haven't caused is causing an issue on the network. And then the next step is to try and fix the problem. And, you know, again, you see, maybe it's the typical network engineer issue. Oh, something's broken. They log into routers at random and try and change things just to see what might make a difference. You can do that on a small toy network quite easily. If it's a larger one where bosses and management are interested on how much money you're making, how many customers you have, you can't just jump in and do random commands. You've got to actually think about it a little bit more. And well, the best procedure for any type of troubleshooting is to start at one place and then deal with each symptom as you work through. Right? Rather than just trying to jump into random places, try and start with something and work through the network to see what's actually going on. Most important thing is not to panic. When I moved out of doing the 24/7 support back in my UNet days, I effectively ended up being the third line support because I was the big boss. And the amount of calls that I had from the NOC, because they couldn't get hold of the second level people, whether they were out watching a movie or the mobile was switched off or something, and it was just oh, the internet's gone down. Or something. It's like, well, hang about, what's actually going wrong? And it may be just a BGP session had gone down that was on the major link to one of our peers. And the result was he couldn't get anywhere, so it looked as though everything was broken. So what we ended up creating was just a checklist. Okay? As we worked out more and more issues in the network, we documented what we did within the Network Operations Center. And we'd use that documentation to do future debugging. So that gave rise to all the checklists that we had. We then worked all those checklists, made sure we started with the really simple things, and then just worked onwards and outwards. So, starting in the second half of the tutorial, we're going to look at checklists quite a bit more. You're going to see an example of how we work through some of those things. And it's how I try and encourage ISPs these days to try and build up knowledge within the network operations to try and help diagnosing these problems. Okay, it may seem a bit daft, it's like it's the usual things you see in anecdotes. You phone up tech support, and the first question that the tech support people ask if your computer's broken is, oh, well, have you switched it on? Is the power socket plugged in, or is it switched on, and so forth? Checklists will end up being a little bit like that, but the bonus is that at least if you're bringing in new staff, which people are doing all the time, bringing in new staff to the operations center, they can work through these and they can actually learn what some of the troubleshooting is. I do quite a lot of workshops, again, not in this part of the world, but a lot throughout Asia, Africa, and so forth. And I insist on using real equipment. Some people are quite happy with remote labs or using simulations and so forth. I'm not really happy with that, because if you've got real routers for doing these workshops, you can break things with them. And you can have great fun actually teaching people how to do troubleshooting. And I get requests, oh, well, can you not just do a troubleshooting workshop? But you can't, because the nature of it is you want to try and troubleshoot the mistakes of people are making while they're doing some of the lab exercises. They may make mistakes in the BGP configurations that gives rise to something which will be unique. Trying to document it is too hard to build a workshop in itself. You can't get people to make deliberate mistakes. But having the real equipment there gives me a big opportunity to introduce all sorts of real-life errors in the network situations, and that's a very good way of teaching people troubleshooting. So if you document everything that you're doing, then at least you're giving a better chance of passing a lot of the knowledge around. The tools that you have available, a lot of people don't actually think about some of the tools that are available to help with troubleshooting. Again, in the second half of the presentation, I'm going to look at more of the network tools that are available and show you how to use them. The first part is really, well, the routers produce log messages. Use these log messages to your advantage. They can give you a lot of information about what's actually going on in the network. So it's important to keep good logs, detailed logs. Use syslog to gather all these things. Have a range of systems that are gathering these log messages. Use tools that are going to parse all these log messages. There are enough public domain facilities available to let you do this quite effectively. Keep your last known good configuration available. Keep a history of your good known configuration available. Rancid was mentioned this morning, I think. That's an example of one tool that will let you do that very, very easily. Keep a history trail of working configurations, all the changes, who made the changes. If there's a problem in the network, you can go and ask the person, you made this change. Why? What did it do? What was the idea? And then you can backtrack and so forth. All these sorts of things help with setting off doing your troubleshooting. Familiarize yourself with the routers tools. Are you switching on logging for the BGP process? I mean, yes, some people have got issues about switching any logging on the router because it takes more CPU. I see it more from the operator point of view of, well, okay, you're switching on a CPU. If your router's running at 70-80% CPU, something's wrong anyway. If it's running 10-15% CPU, switching on logging to lose another 2-3% isn't really going to be an issue. And then you can dump all these logs, as I was saying, off the router. The logs are not much good to you on the router if the router ends up actually crashing and you lose everything altogether. So are they being captured off the router somewhere else so that you can actually look at them, parse them sensibly? You can look at the BGP debug process. I mean, people say not to use the debug facilities available on the router at all. Use debug only if you're directed to by technical support. Well, yes, that's for simple users. You guys all know what you're doing. If you're going to use the debug facilities, you've become very acquainted of what you can and can't do. Running a debug on the entire BGP process, if you've got the full internet routing table, doesn't make a lot of sense. 182,000 prefixes, getting full debug messages is probably going to tie up all the resources on at least the control part of your router. So that's not too useful. So check the vendor documentation on how to do it properly. I'm going to have some examples throughout this showing you how to do it, say in a Cisco case. But Juniper and everybody else, it's going to be the same idea. Try and do it carefully, sensibly. Pick on the prefixes that you want to troubleshoot, not just everything. Traffic and flow measurement in the network. Unexplained traffic, well, unexplained changes in the traffic levels on an interface, for example. If an interface is normally running at, I don't know, 10 meg and it jumps up to 100 meg, well, maybe there's something gone wrong. Has another link somewhere failed that you need to go and try and fix? Has a peering gone down? Whatever. Keep a note of things like that. There's also a security tutorial happening this week at NANOG covering NetFlow to look for denial of service attacks or worm activity in the network and so forth. Well, you can use things like NetFlow and similar traffic flow tools to find out, or at least help with troubleshooting in BGP. All these facilities are actually available. Listen to customer feedback. Customer says the internet's broken, then, well, maybe something's wrong with your outgoing peerings. If a customer can get to bits of your network and not other bits of your network, as you'll see later on, well, there might be something within your own backbone that's not working right. So you try and look at customer feedback for clues and so forth. So those are the tools that are available to you. Now, let's have a look at the local configuration problem. So in this section, I'm just going to pick through the router, what the router can do, has got wrong, what can go wrong within BGP, within the local network, and between you and your immediate peers. So it's what I've called the local configuration problems. We'll pick through these 4 examples, give you some scenarios out of each one. First one is about peer establishment. I mean, it probably belongs to the frequently asked question list. I'm trying to bring up BGP and I can't. Well, the simple questions are, well, BGP uses port 179, TCP 179. What do your filters say? Do you allow TCP 179 through? How many people forget that? They think, oh yes, I'm running on the internet, I need a firewall. So they put, bang, a firewall between their router and the outside world. And, well, if port 179 can't get through, you're not going to get a BGP session. You need IP connectivity. If you're bringing up iBGP, for example, you need to know how to get to your iBGP neighbor. And this is a classic one from setting up the workshops when I'm teaching people how to use IBGP within their backbone. They don't have the route to get to the actual IBGP neighbors. Is it in the IGP? Well, yes, you can use a static route, but this doesn't scale, and anyway, you won't get failover. So look at issues like that. So getting all that right, we've got the open messages are exchanged. Peering addresses have to match in the TCP session. If one router here has got one address, another router here has got a different address, the two of them aren't going to speak to each other. The one here has got a different address for the neighbor, I mean. They aren't going to be able to speak to each other because you have the address mismatch. This one here with the configuration is expecting to see an IP address that matches what's in its configuration coming from the neighbor. If you don't, nothing. The AS number has to be the same. You can't set up an IBGP session with a different AS number. Stuff like that. So the common problems, sessions aren't established. It's usually down to no IP reachability or some configuration problem. If the peers are flapping, then it's pretty much a layer 2 issue, usually. So let's have a look at, take this example. So we're looking at an IBGP, trying to bring that one up, and we're looking at eBGP, trying to figure out the problems there as well. So we sit on router 2, we do just a show run to see the configuration. So we're in AS number 1, which is right. We've switched on logging for BGP, which is fine. Neighbor 1.1.1.1 is in remote AS1, so we've got that address of router 1 in there, so that looks good. Neighbor 3.3.3 is in remote AS2, so that looks fine as well. But the issue is BGP isn't up. Okay. So we look in router 2, we do a show IP BGP, and we see nothing. Okay, it's not up. The internal BGP session is sitting there in an active state, which means that router 2 is trying to bring up a session with router 1, but there's either no response or basically nothing there. And the same is true for router 3. What you find, and well, certainly in this case, the state will change between active, idle, connect, and so forth as the BGP process goes around trying to bring the session up. So what do you look for? Well, is the AS number configured correctly? So we check that. Router BGP1, neighbor 1.1.1.1 is in remote AS1, so that's an IBGP peer. That looks fine. You quite often find mistakes of people setting up IBGP. The AS number, they might just switch digits. And certainly with the bigger AS numbers, for those of us with like 2 or 3 digit AS numbers, it was easy enough. I find these days with people using 5-digit AS numbers, getting the numbers swapped around is quite a common mistake. So it might be as simple as that. So you're not going to get the session coming up because the remote router is actually in the same AS and it sees an AS number mismatch. Is the remote AS assigned correctly? Well, yes, we've got the remote AS there, AS number 2, that looks okay. Okay, so we check that documentation diagram, all the rest. As I say, we start nice and simple. Some things may be very obvious. Have a look at the TCP connections. So doing a show TCP brief, for example, shows the TCP connections. We've got the local host sourcing from port 179, heading off to 3.3.3. We're sitting there in a listen state. Ditto with address 1.1.1.1. Okay. So that looks all right. Now, here's the first example where you might use a debug on the route. We do a debug of the TCP transaction, so that shows you what TCP sessions are opening to the local router. We find that we get TCP connection attempts coming from this 4.4.4.4. Okay, and that's like, well, hang about, who's 4.4.4.4? Okay, 4.4.4.4 wasn't in any of the configurations here. So, so why is the remote using this address? So there's some configuration error somewhere. What about us? Well, we do a debug on our BGP. We see a BGP on, for router 1, it's active. Our local address is 4.4.4.5. Connection is refused by remote host because the remote host is expecting, well, another address, a different address. So what's going on? Why are we trying to do this? How do we get to 1.1.1.1? It's known via static route through the serial interface serial 1. Okay. Source address in the BGP session is the outgoing interface towards the destination. Okay. So that's what's happening. When you bring up a BGP session with the neighbor, internal BGP, the source address is the IP address of the outgoing interface. It's a common thing that people forget when they bring up iBGP. Bring up iBGP, for stability reasons, you use something like the loopback interface in Cisco's case. You use the loopback interface. That ensures if any interface or any backbone interface in your router goes down, you will have an alternative path to the remote loopbacks courtesy of the interior routing protocol. So what was missed in this configuration here was to specify the update source. If we say neighbor 1.1.1.1, update source loopback 0, well, our loopback on the local router was 2.2.2.2. And of course, the remote router was configured to bring up a BGP with 2.2.2.2. And so now we have an address match, and then the BGP session should come up. So that was the issue. We hadn't specified what the source address was, so the router would use the default outgoing interfaces, which weren't actually configured in the iBGP session. Such a common mistake that people make when they try and bring up iBGP in the network. They forget to specify the source address. Of course we assume that we've checked IP connectivity. I can't imagine that that could be an issue. I've seen things like that happen before, like the wrong IP address in the router or something like that. But you assume that the IP connectivity works. We make sure that IGP can function. We can see the remote router. We then check TCP to find out what's going on. So you just do the simple TCP transactions case, debug the TCP, and then you see what source and destinations addresses were actually being in use. Okay. Do the match the configuration. If not, fix it. If they do, then, well, you've got something else. Okay, so we've now got the iBGP session between router 1 and router 2, but we still have an issue with the eBGP session. Remember, on router 2 we put in the update source loopback 0, but the eBGP session is still not coming up. So what's up? Well, we try and ping the remote. Okay, we check the TCP connectivity. We ping the remote on 3.3.3.3. That seems to work. We get a response. So the routing towards the destination is right. Okay, so this starts getting puzzling a little bit. The next thing you try and do is to do a ping but specify the source address. Because again, if you're sitting on a router, you do a ping to remote address, the ping source will come from the outbound interface. It won't necessarily come from the interface you're trying to set up the eBGP session to. So we're doing a remote ping to 3.3.3.3, but we want it to be sourced from 2.2.2.2, which is the loopback address of router 2. You try that extended ping, and guess what? Nothing happens. It means that the remote router, router 3, doesn't know how to get back to the router 2 address. So why is that? They don't have a route. They've forgotten to put a static route in their configuration to point back to us. So that can be fixed. Okay, so put the static route in, but we're still having problems. Now the second thing can be issues highlighted in red down there. The external BGP neighbor is not directly connected. Remember eBGP, when you bring that up, there's an expectation that the neighbors are directly connected, physically connected. But we've had to set up a static route to get to the 3.3.3 address, the remote router. Okay? But we haven't actually told the router, so again, to be pedantic about it, you need to tell the eBGP session that this is a non-connected, directly connected remote host. And what was happening is the eBGP multi-hop specification was missing, because the remote router was coming in with more than a time to live of 1. So we'll make the time to live 2, and then, well, we should be able to bring up the eBGP session. The 2 here is an example. It could be 3 or 4, depending how far away the remote router is. And this is actually one reason why I personally dislike the use of eBGP multi-hop, because I seem to spend a lot of time helping people troubleshoot problems caused by it. And I'll talk more about eBGP multi-hop and the multi-homing tutorial and why a lot of ISPs generally think it's a really bad idea. But it can cause a lot of issues because people get the TTL value wrong, or they forget altogether to specify a TTL anything different from 1. And some people even put TTLs of 255 in because, hey, that's what it says in the manual. And that can end up with really, really bad situations where the eBGP session quite happily carries going on through your backup connection even though your main link is down. And yes, I've seen more than enough of those in my time to say that this is probably not such a good configuration practice. But anyway, some people are quite happy to use eBGP multi-hop as a matter of course. Anyway, so we put in the eBGP multi-hop configuration, and that should bring the session up. Make sure that the remote host is doing the same thing as well, and make sure the time to live that you need is exactly the right number for the remote host. Well, guess what? It's still not coming up. Okay, we think we've done everything right, so there's still some issue. So doing a show IP BGP summary for that particular neighbor, it's still sitting as active, remote AS is right. We've got messages received, messages sent, so the numbers are incrementing, so there is some chatter happening between the peers, but there's still an issue. The peering is still not up. What else can be wrong? Well, we have a look at the BGP events. So we can do a debug on the BGP events, and in the red you see receive notification. Peer in the wrong AS. Okay, that's the notification message that we got from the neighbor saying, peer is in the wrong AS. They're saying, oi, you're not in the AS that I've been configured for. Okay. So somebody has done a configuration error. So what we find is, for example, R3 might have typed in remote AS10 rather than the remote AS1. So that can be the typical typos that are very, very easy to make, especially with the larger AS numbers. After you make that correction, hopefully then the session will come up. So summary of all this, well, the first thing is to remember to allow TCP 179 through edge filters. People frequently forget that, especially those who are very aggressive at filtering on the edge of the network. So I put an example access list in there. Be very careful with the multi-hop eBGP. As I said earlier, I really dislike it, just because I spend far too much time helping people troubleshoot it. Remember to source updates from loopback interface, especially for iBGP. Watch for filters anywhere in the path as well. Even though you may not have filters, your neighboring ISP might have filters that could stop BGP from coming up. Also, my warning about using the TTL value carefully. Next one, passwords. You can have lots and lots of fun with passwords on BGP sessions. I mean, not to mention software interoperability issues, but actually trying to bring links, iBGP and eBGP connections up simply by using passwords on the sessions. So we've been through all the previous troubleshooting steps. We still can't get the session up. We've really no idea what's going on. So we have a password set on the BGP session, whatever it is we're using. So we have a look at the log messages to try and find out what's going on. The BGP log messages complain about no MD5 digest from the neighbor. Okay? No MD5 digest means that there's no password has been set on the neighbor. So you've got one set, but there's nothing coming from the neighbor. No MD5 digest. You look on the router 3 configuration. Obviously, if this is not your router, you can hardly log into your neighbor's autonomous system and his border router and check his configuration. It's something that you have to work with them to do. Have you got a password? If you haven't, can you put it in? Type thing. Okay? So you fix that issue, the peering should then come up. What other problems can you get? Well, you can get the wrong password. Invalid MD5 digest. That's when the MD5 digest doesn't match what your idea is. It means that one of you has the wrong password. So rather than getting in the blame game of telling your neighbor, oh, well, you've typed the password wrong, it should be this, it's probably better just to start it fresh on both routers. He may have typed it in perfectly okay, you may have got it wrong. So it's better, easier just to start fresh with a new password and then see what happens. So you get the invalid messages, you fix the password, the session then should come up. Okay, again from my experience doing the workshops and so forth, this is a frequent thing where people even think they've typed in the password properly. It can be simple as swapping O's and zeros and I's and L's depending on the character set you're using on your terminal program. All these things are quite frequent causes of mistakes. So this should really be enough to try and bring up the BGP sessions. The password is a fairly common issue now, certainly with more and more ISPs insisting that passwords should be put on BGP sessions. Finding more and more situations where, can't bring BGP up, and people arguing about whose password is right and who's typed it in properly and so forth. If you know where to look, you know where to look in the BGP log messages, you should get very quick clues as to what's going on. So yes, the common problems, as I was saying, missing password, it needs to be on both ends. At one end is missing, then you get the missing MD5 digest message, cut and paste errors, the typo errors, transcription errors. Don't email BGP passwords around in clear between you and your peer. Arrange some way of exchanging them secretly. For example, use PGP to encrypt the message. Watch out for capitalization, extra characters, white space, confusing different characters, your character set in your terminal program. All these things have caused problems before. The common solutions, well, just check the messages. It's amazing how many people won't switch on BGP logging. Oh, well, there was a bug 2.5 years ago, whenever it was, with BGP log messages that could be exploited and cause routers to crash. So, why are you running software that's 2.5 years old? There was a fix issued whenever long ago it was that you should have uploaded, and then there isn't an issue anymore. So, my answers tend to be like that when people give excuses why they haven't done certain things. And yes, avoiding the dreaded cut and paste. People are quite happy with cutting and pasting all over the place. I'm more happy putting entries into files on a central server than TFTP loading them into the router. That seems a lot safer to me, rather than just logging into the router and doing random cut and paste. But you'd be amazed how many people are still quite happy to cut and paste whole configuration chunks into routers, even using what I would call non-resilient terminal programs. Okay, what about flapping peers? Could be something like this. They're generally layer 2 issues, as I was saying before. The symptom you see is that the eBGP session just flaps all the time. It establishes, doesn't really get anywhere useful, it maybe exchanges a few announcements, and then it stops. Okay? And then it restarts again, just when the BGP retry timer expires. It reestablishes, tries to send some more updates, and then it falls over in a heap. Okay? If you've never seen it before, it can be pretty frustrating. But the big clue is the layer 2 thing. We had loads and loads of these, and certainly in the 90s, when we had lots of ATM and frame relay infrastructure that would be used to connect different autonomous systems together. These days it's probably less of an issue with more and more clear channel or clear optics between ISPs. But when you had a layer 2, a sort of cloud like that, you could certainly get all kinds of issues. So the first thing to do is make sure that the logging is switched on. If you don't have logs, you'll have no clue of what's going on whatsoever. Now the R1, R2 peering, is generally, this happens when you've got some third-party layer 2 network there. So you've got your circuit, your virtual circuit, whatever it is, from some third party. And you see messages like neighbor 111 down, BGP notification sent, hold time expired. The clue is the hold time expired. That means that basically BGP has got a hold time. It expects to hear 3 keep alives or an update. If it doesn't hear 3 keep alives within the hold time, it then pulls the BGP session down. Because it's basically saying, hey, the neighbor's gone away. The circuit may have dropped or the router could have crashed or whatever. Okay, so want to fail over BGP and fail over to an alternative path. Okay, so hold time expired means we're not getting the keeper lives from the other side. If we're not getting the keeper lives, there must be a problem of some sort. So let's take a look. If you do a show IP BGP summary, for example, you can see the messages received column, the message sent column. The input queue is sitting at 0. The output queue is quite big. Always worry when you see an output queue that's not 0 or 1 or 2. If it's big like this, that means you've got, well, 97 BGP packets, I guess, sitting, waiting in the out queue. And that's not good. It means something's got stuck somewhere. And what happens is the hellos, the keeper lives that BGP sends, have got stuck behind the update packets. Now the update packets are padded out to the maximum size you can send over the link, so whatever the MTU is. If it's, say, 1500 bytes, the BGP updates are padded out to fill the packet as big as you can. So it's expecting to be able to maximize the usage of the link. And it clearly means that, well, a keeper live will be very small. The updates will be very, very big. It means the network can't send big packets across. You've been able to bring up the BGP session, but that's been done by small packets. There's nothing more than, hey, this is me and this is what I have, and do you want to bring up BGP? Whereas sending updates, you can get a load of BGP updates in one actual packet to send to the neighbor. So this is the classic can't send big packets through the network because of some MTU problem. The first few times you see it, you won't recognize it, but then when you see something like this, it's like, okay, there's something wrong within the network itself. And so you've got to try and get it fixed. Just to confirm that it really is an MTU issue, try using ping. If you use the standard size ping, 100 byte packets, that gets through no problem whatsoever. Try send 1500 byte packets, which is what the second extended ping does, no response whatsoever. Okay? That just proves it to you. So your early suspicions that could be an MTU problem have been proved by this test. So it's a very, very simple test using ping. Of course, you get some ISPs who think it's wonderful to block ping, and this test won't help you at all in that case. But generally, seeing something like that is pretty much caused by MTU issues. Right, so the diagnosis, keeper lives are getting lost because they get stuck in the router's queue behind the BGP update packets. BGP update packets are big, as I was saying earlier. The keeper lives are small, so they will get through the network whatever the MTU issues are, whereas the big packets would get stuck. Solution is, well, go to the provider of your L2 infrastructure. If it's, well, your transmission folks, well, it's easy, you can go tell them. If it's your supplier, well, you have to go and beat on your supplier to go get them to fix whatever they have. As I say, I've seen this less these days, certainly when there's fiber between networks. I still see it where people are still using ATM or frame relay or some other thing to provide the infrastructure. And generally there's a layer 2 issues to try and sort it out. But I suppose the only caution is passing it to layer 2, people expect a lot of ping pong to go on. They might say, no, there's nothing wrong. I can send my whatever things through, which is issues I remember from the past. It was like, well, you know, we did the test and it all worked. Well, how did you do the test? Oh, well, we sent some ping packets. Well, what size were they? Oh, just the standard ones that Windows does. Yeah, we're trying to send, you know, everything that will fit in the network to 1500 byte. Well, why would you want to do that? Well, we're trying to use the network you supplied. You know how the conversation goes, so be aware that you'll have to enter that one yourself when trying to do this. Don't let them blame the router as being a problem, or, oh, well, it's such and such as bad software or something. Don't let them go down that path, because people are quite happy to pass bucks to somebody else. Other issues, well, it could be the remote router rebooting continually. There, if you see a 3 to 5 minute BGP cycle time, then it might be the remote router rebooting. Suddenly, if they're running older software, it could be they can't take the full internet routing table that you're sending them. So the software crashes, or the BGP process restarts, or something like that happens. So there, it's something you've got to get onto the remote side and say, do you realize that your BGP process is resetting every 3 to 5 minutes? People may not be aware of it. Could be traffic shaping, rate limiting. People rate limit big packets, don't rate limit small packets. Or they randomly throw away big packets. Or they get rid of small packets, or maybe they're trying to block voice services. So if they block voice services, they throw away the small packets and let the big packets through. It can be all sorts of craziness like that I've seen, and that will stop BGP from working properly as well. People have switched off path MTU discovery. That could cause issues, and so forth. Instability in layer 2 point-to-point links, so you can go through the whole gamut of faulty muxes, bad connectors, interoperability issues between different equipment, PPP problems, satellite, radio, weather, especially for microwave. Weather seems to get in the way an awful lot. The list is endless, but you're the BGP person. It's not really for you to try and help your layer 2 folks fix their network. But you can give them all sorts of reasons, like it could be this, could be this, could be this. I've documented the ones that I certainly have come across and have had to use in the past. But basically for you trying to troubleshoot this, ping is the tool. If your remote neighbor is filtering ICMP, well, heaven help them anyway, but I mean, try and encourage them to at least let you ping their remote router to help you troubleshoot the problem. Okay, so we've fixed all that, and BGP session is now stable. Next thing we want to look at, missing routes. Oh, well, there's something gone wrong with the software. Oh, there's something gone wrong with whatever. But missing routes can be caused by all sorts of things. So once you've got the session established, you get the updates exchanged. And what the updates contain are basically all the network layer reachability information, the BGP prefixes. Okay, so we advertise the locally known routes, and we have basically only the best paths. Once we've sent all the prefixes that we know, all the best paths that we know to our neighbor, whether it's internal or external, we then only send incremental updates. If we've got no updates to send, the BGP process will send a keep alive message. Again, depending on which vendor, it will be like every 30 seconds, every 15 seconds, or every minute, or whatever it is. Some people tune the keep alives down to very, very small values just to get better failover for BGP for their case. But whatever it is, if there's no update message, BGP will send a keep alive. So if a best path is received from a peer, an eBGP peer, it's advertised to all peers, whether they're external or internal. Best path is received from an iBGP peer, it's only sent to external peers. And you need to have a full iBGP mesh unless we're using route reflectors. More about full mesh iBGP and route reflectors later on. You can have lots of fun and games with things going wrong there as well. Okay, so again, 4 examples, 4 situations to look at. First one is originating prefixes. There's a common problem when putting prefixes into the BGP table. I suppose in the early days, a router was a router and it just had a routing table, and people really didn't think what the routing table was. It was just a collection of everything the router knew, and people waved their hands and that was it. But these days it's actually pretty important because the router has different routing processes. We run maybe OSPF or ISIS. We run BGP, we've got static routes, we've got connected routes. They all actually occupy, they have different tables. So there's a BGP table. There'll be an OSPF table, or link state database, an ISIS one, static routes one. They're all different. And all these tables are used to create the RIB, the routing information base, or the routing table that we waved our hands about in the old days. Okay? The BGP table is not the same as the routing table. The BGP table is used to build the routing table. But each routing protocol has a different priority. And again, depending on which vendor you're using, some will be more important than others. Okay? So you may have an entry in OSPF and an entry in BGP. The OSPF entry may override the BGP entry because the OSPF is more important than BGP. Or it might be the other way around, depending, again, whose software you're using. Now, to get a prefix into BGP, generally it needs to exist in some other routing process too. For example, it could be a static route pointing towards a customer. So for putting customer routes into your iBGP, that's generally what people do. They point the static towards the customer interface. You mark it as such in BGP, and BGP will BGP process will inject that into the BGP table. Or if you're generating an aggregate in your network, typically you have a static route pointing to null, and that will inject the aggregate into your BGP. But people seem to forget to do this. And again, I think it depends on which implementation you're using. A network statement in BGP, well, we've got the example there. It's very, very terse, just so that the slides aren't full of configuration. I've done a show run on the router 1 configuration. It says network, okay, 200.200.0.0/22. So yes, we've got a 200.200 network in BGP. So it's in the BGP configuration. Now in Cisco case, this says, well, if you see this in the routing table somewhere, put it into the BGP table as well. It won't by itself put the prefix into BGP. Okay, so if we do a show IP BGP, we see that there's nothing there. There's no 200.200.0.0. We do a show IP route for 200.200.0.0. We see there's nothing in the routing table either. And that's the clue. Now, when doing workshops, I hark back to the workshops a lot in this presentation because, well, to be honest, that's where a lot of the troubleshooting came from, because working through with people who are learning how BGP operates, they make most of these mistakes. And forgetting to put this static route or route into the routing table means that they don't see it in the BGP table. And you see this then being transferred into real life as well. People, why am I not announcing this prefix? I have no idea why. I put it into the configuration here. And it can be a very, very simple reason why. One example could be that they've forgotten to put the static route in. So we've put in a static route to the null interface. This is generally a good idea to do anyway. As those folks in the security tutorial are finding out, this is like almost mandatory. If you've got an address block from the registry or upstream ISP, you put a static route to the null interface for the address block. So any traffic coming in that doesn't have any good place to go in your network, i.e. no more specific entry in your network, it'll get dumped into the null zero interface and not go charging through your network, causing issues. So this is generally a good thing to do anyway. But by putting the static route in, it ensures that BGP will announce the prefix into the BGP table. Once we've done that, we look at the RIB, show IP route. We've now got the static route to the null interface for that /22. And voila, the BGP table now has the /22 as well. Okay? So that's a very obvious one. When you see that, you've got the network statement, but you don't see any entry in the BGP table. It basically means you've forgotten the equivalent static route to match it. Trying to generate an aggregate. For those of you who use something like the aggregate address, which I personally don't use and won't use, that's one way of generating aggregate, but you see the configuration there, aggregate address, whatever, for network 7.7/16. You see, what do you see? Show IP route for network 7.7/16 and any sub-prefixes of that. Well, you see the /32, but you don't see any entry in the BGP table. Because what happens is, and I think this is probably peculiar to this software, is aggregate address needs an entry in the BGP table as well, a sub-prefix in the BGP table. And that's why I personally refuse to use the aggregate address command. I've been burnt by this a couple of times in a long, dim and distant past, where entries in the or sub-prefixes in the BGP table have dropped out because, say, customer links have gone down or whatever, and we've lost the aggregate for a large chunk of address space. So this is a little bit of a gotcha that catches people out who use the aggregate address command. It's like, well, I've got it there, and it's doing my summarization, but it's gone. Why is it gone? Because the sub-prefix has disappeared from the BGP table as well. So what you need to do then is put in the little hack of putting in a network statement for a sub-prefix of that aggregate you want to generate, and then you're set. Of course, what some people forget to do is they put any old entry in the BGP table, then they forget to put a matching static route for that network statement. So you need to kind of watch how you're doing this. So that's some issue that can result with using the aggregate address command. So just some of the troubleshooting tips, the rules behind the BGP network statement. You need to have the exact route in the RIB as well before it will appear in the BGP table. The aggregate address command looks in the BGP table and not in the RIB, because the aggregate address is, of course, generating a BGP aggregate. It's not generating any other aggregate. And you've got commands like show IP route for longer is useful for finding components routes in the RIB, and show IP BGP longer is good for finding the equivalent routes out of the BGP table. Okay? Show IP BGP is different from show IP route. Issues with update exchange. This is where I come to route reflector fun. I mean, I strongly recommend route reflectors really for any new network these days. Any startup. I mean, I've helped people starting up from nothing, 2, 3, 4 routers growing to bigger, and I say, look, just start with route reflectors. It's not worth setting up a full mesh IBGP and then going through the pain of migrating. It's not much pain to migrate. Nothing like migrating confederations was. But it's still, you need some reconfiguration to be done. And it's just, well, if you're going to grow your network, if you start off with a scalable design, starting with route reflectors from day one is no big deal. But then people start reading documentation, books, and so forth about how to design route reflector networks. And of course, a load of the documentation, unfortunately, was written in the early days of route reflectors when the implementations were quite limited. These days, of course, a lot of the early, what I call problems, have been fixed. And of course, people don't really, I suppose, I would say, don't understand how route reflectors should be deployed. I've seen networks where they've got 100 routers, and they've got 2 route reflectors. And the 2 route reflectors are sitting in one POP, in the same rack, from the same power supply. What happens when the power goes off? Oops, they have no IBGP whatsoever. And that somehow becomes their equipment supplier's fault. I can't quite work that one out. Whereas, you know, the proper design that I've grown up with, when I was around before route reflectors were even invented, what I've grown up with is the dual route reflector per point of presence design. But oh yeah, people love breaking the rules. And the worst thing is there's been enough documentation of designs out there saying, yeah, this is the cool way to do it. Have 2 routers in your network, and yeah, you can have 250 IBGP neighbors in a router, no problem. So people design it that way, and then wonder why things break. Other recommendations that I've had were, yes, you've got to make the cluster IDs the same. You'll see all the problems coming. Okay, what about this one? 2 route reflector clusters. You've got router 1 as a route reflector for router 3, so that's on the left-hand side. Router 2 is a route reflector for router 4 on the right-hand side. Router 4 is announcing a network. Pick on network 7, for example. Router 2 sees it, but router 1 and router 3 do not. Well, there's got to be something wrong with the BGP implementation. Well, no, because this is obviously working properly for other people, so there's something wrong with the configuration. Let's have a look. We look in router 2. Well, router 2, remember, was the route reflector on the right-hand side. Did router 2 advertise the route to router 1? So you've got a nice tool which says show IP BGP, blah, advertised routes. And it says network 7, next hop 4444, well, that's router 4. Yeah, it's done it. It's advertised network 7/8 to the neighbor. We now go to router 1, which is the route reflector for router 3. Did it get it? Show IP BGP neighbors that we've heard from router 2. Nothing. Okay, so 2 sent it, 1 didn't get it. So there isn't something in the middle that's picking packets off the network. So something's gone wrong. What's gone wrong? And this is where we try and show you how to do debug a little bit more sensibly. My first ones were like just debug IP BGP and see what happens. You don't really want to do that on a real live network. Pick the prefix you want to debug. So set up a simple access list, put the prefix in there, and then debug using that actual access list. Then you don't get debug messages for thousands of updates. Okay, so we set up the debug, and then we tell R2 to resend updates. So in R2 we do the clear IP BGP out, which gets them to resend all their updates, and then we have a look in the debug logs. Okay, so it says received update, attribute, next hop, whatever, originator 100.1.1.1, cluster list, whatever. And then the next line it says denied due to originator is us. Okay? The originator ID, the router ID of the originator 100.1.1.1, that's the same as our router ID. This basically tells, it's a loop detection thing. It tells the local router, well, don't need to get this prefix because you've originated it, so you already know where it's come from, so ignore it. Okay? So it's a loop detection thing in BGP. Unfortunately, what's happened is this ISP, he's had one router, he's set the router ID, he's then moved the router to somewhere else in the network, he's forgotten to change the router ID because, well, he forgot, and he's trying to bring up his iBGP, he's got two router IDs the same, and of course nothing works. And this is where I rail against people physically setting the router ID on the router. Now, you have to do it in some implementations, I accept. In Cisco's case, you don't have to because it's generated automatically from the IP address of the loopback. And if you're using a loopback for 101 other things that you should be, then you will have a unique IP address for the loopback anyway. Otherwise, your OSPF won't have worked, or your ISIS won't have worked. So you won't run into this issue. But people insist on setting the router IDs by hand because some book said it. Okay? If you're going to set router IDs by hand, you need to be careful. I mean, I've been in networks with clashing NSAP IDs for ISIS and so forth, and those are hairy to try and work out where they're from, what's causing them, and so forth. Okay, so summary is pretty much all that I've said. Router 1 not accepting the route that R2 sends from its client R4 because R1 and R4 have the same router ID. So, solution, don't set it by hand. If you want to set it by hand, come up with a really good plan and stick to it. Okay, the second one. Here we've just got a route reflector cluster. R1 and R2 are route reflectors, 3 and 4 are route reflector clients. R4 is advertising network 7/8, R2 sees it, R1 and R3 do not. That's another route reflector issue. Do a show run in router 1 and router 2? Well, router 1 and router 2 are in the same cluster because they've got the same cluster ID. So follow the books. That's what they all say to do. This is a good thing to do, say the books. So what's gone wrong? Why does this not work? Why does R3 not see, well, R1 and R3 not see R4's prefix? Did R2 advertise it to R1? Should IPBGP advertise? Yep, it did. R1 receive it? No, it didn't. Same debug. Have a look what's going on. We resend the updates. Again, get R2 to resend the update towards R1. The message this time denied due to being reflected from the same cluster. If you've got two route reflectors in the same cluster, the clients need to talk iBGP to both route reflectors. They can't just talk to one. They have to talk to both because you've got another loop detection, or at least trying to save update bandwidth with the route reflector. So if one route reflector hears a prefix and it hears the same prefix from another route reflector with the same cluster ID, then it's just going to say, well, I've already heard this, so there's no point getting a duplicate announcement. The only problem is, as in this situation, if we just try and move back. Can I try and move back? Yes. Nope, that didn't work. Did that work? Yes, move back. The only problem is router 4 has not got a direct iBGP session with router 1. That's what was missing there. So router 1 is, well, I'm hearing from router 2, it's in my cluster. So I'm hearing it anyway, even though it isn't. It doesn't do the sanity check that is actually hearing the prefix, just says, well, it's the same cluster ID, we're avoiding loops, so we just ignore it. Okay? So that can be the second issue here. So summary of that, R1 is not accepting the route when R2 sends it. If it sees its own router ID and the cluster ID attribute in any received prefix, it will reject that prefix. And that's how a route reflector avoids redundant information. Now, why? Well, in the early days, I think for the first 3 months or so, when route reflectors were actually deployed within router software, it was claimed that route reflector client redundancy should be achieved by having dual route reflectors in the same cluster. That was how you get redundancy, which is fine, but then you have to make sure that all clients appear with both route reflectors. So people doing the fantastic designs of 2 route reflectors in the network and 250 clients, well, it can get pretty easy to miss one of these. And having been involved in so many situations where this has been the cause, it's just my standard device is at the bottom. Use overlapping route reflector clusters for redundancy. A client of a route reflector can speak to another route reflector in a different cluster. There's no problem with doing that. So what about the extra information? That's what BGP's got its best path selection process for. It's one more check. It's a lot better than having black holes within your network. Okay? So my strong advice, don't configure the cluster ID. There's generally no need to do it. If you want to achieve redundancy within the cluster, just have 2 overlapping clusters. I'm going to talk about that more in the Introduction to BGP tutorial, how that works. And the ironic thing is, I mean, I don't remember when we deployed route reflectors in the UUNet UK network, must have been, I don't know, 95, late 95, 96. It was not long after the software came out in beta from Cisco, actually. And we deployed it. And we just did that from day start because there was no documentation. There was no advice. It was just like, well, we need this for redundancy, and we just do it. And we had people telling us, oh, well, I don't know if you can really do that. But it worked for us. And then documentation appeared saying that you have to do this, set the cluster ID thing, and then we've had endless problems with that. And of course, people move routers around and forget to reset the cluster ID value and so forth. Endless problems. So it's generally simpler not to do it. And I get questions when last time I gave this troubleshooting tutorial, people said, do you really do that? But it's such and such a book, and I've just gone and designed a huge network that's set all the cluster IDs, and it's, well, you don't have to go and change it. But if you're aware of what the issues are, and you document everything properly, you're not going to run into a problem. But if it's just a case of you've done some kind of random deployment and there's no documentation, and yeah, you're going to end up with issues. And it's probably better just to rely on the system's defaults, because they generally work as well, if not better, than trying to manufacture a lot more things by hand. Just some more troubleshooting tips here. You've got the show IP BGP neighbor advertised to find out the prefix is advertised by a neighbor. Show IP BGP neighbor routes shows you what you get from the neighbor. Show IP BGP received. Don't really talk about route refresh or soft reconfiguration in the troubleshooting part, but received is if you use something called soft reconfiguration, which is special for Cisco. Juniper have some equivalent that lets you store the prefixes that you receive whether you use them or not. And that lets you find out what arrives on your router before you apply any policy. And that's actually a pretty useful troubleshooting tool as well. I mean, route refresh lets you, well, let me see, do a soft reset of the BGP session without actually having to physically tear it down. So that's the standard for today. But this soft reconfiguration command is still useful if you're trying to troubleshoot your inbound policy. So it lets you find out what your neighbors have sent to you before you've applied your own policy. Yeah, so this is an example of how the soft reconfiguration would work. So for example, show IP BGP neighbor routes lists what gets through your policy, whereas show IP BGP neighbor received shows what you've actually received from the peer. So you see that the 169.254 network has actually been blocked by whatever your inbound policy is. In fact, 169.254 is one of the bogon /16s. Okay, filtering. Oh yes, we can have lots of fun with filtering as well. What sort of filters? Well, we can filter on prefixes, of course. We can have AS path filters, and they can have endless fun with AS path filters. And there's community filters, which probably less of an issue. And route maps can cause all sorts of things as well. These can be applied incoming or outgoing on any BGP peering. So what can we do with them? Well, first thing probably we should try and figure out is try and work out which filters are applied to a BGP session. So you can do things like show IP BGP neighbors for a particular neighbor, or you can do show run, include neighbor, and try and pick out what filters are actually there, pick out prefixes, have a look at those particular attributes, and compare the attributes against the filters. That's your general target and how to try and troubleshoot the update filters. For example, we're missing network 10/8 in R1. Okay, so R2 is announcing network 10/8, for example. R1's not seeing it. What's happening? Okay, we're not looking at route reflectors or anything like that. Here it's just a simple update. An update is missing from R1. It's not getting it. So we sit on R1, we do show IP BGP neighbor routes, we don't get anything whatsoever. Why? Well, R2 is originating the prefix, so we can do the show IP BGP neighbor advertised, but we don't actually find that it's sending to R1. Okay, we do show IP BGP on network 10/8, we see it there in the BGP table, so we're certainly putting it into the BGP table, but it's not being advertised to R1. So that could only really mean that there's something wrong with our outbound filters. Okay, we'll put it in the BGP table, as you see in the second box. The first box shows that nothing is being sent to R1. Why? Have a look at the filters. Well, if we do a show run and look at the configuration for the neighbor 1.1.1.1, the neighbor basically has a configuration that says filter list 1 out. What does filter list 1 do? Well, filter list 1 says show IP AS path. Well, sorry, filter list 1 is basically an access list, an AS path access list that allows prefixes from the local AS. That's what the $$ means, prefixes from the local AS. So what's happening here? Router 2 should be sending prefixes originated by the local AS out towards AS3. That's what should be happening. So it looks fine. Permit $. Yeah. Show IP BGP filter list 1 is blank. There's nothing. If you do a show IP BGP filter list, it takes the BGP table and runs it through filter list 1. So this says that no prefixes are originated by the local AS. And you go, huh? But I just did show IP BGP for network 10, and it's there. It's in the BGP table. And then you've got show IP BGP filter list 1. So there's something saying there's something wrong. It's in the BGP table, but you run the local BGP table through the filter list, and it's not there. So then you do it by hand. You can do show IP BGP regular expression $, which just replicates what the filter list is doing. And sure enough, you get the network 10. So the filter list doesn't match, but when you type it in by hand, it does. What's the issue? Victim of cut and paste. Right? Copy and paste the entire regular expression line from the configuration. Show IP BGP, and then you cut and paste from the config. You see, the end of line is where the cursor is. There's a space after the $. Right? The router will match that. Now, for many, many years, this was a major issue. Okay, I think it's been fixed in the most recent ones, where any white space at the end of the regular expressions actually dropped. But oh boy, did this catch out so many people over the years. Okay, a white space at the end, as simple as that. I mean, it seems such a trivial thing to put in here, but people still have this issue, until even very recently, they still have this. It's what I was saying earlier. Never cut and paste. Always type it in fresh, because you end up with situations like this. It's considered part of the regular expression, so it'll be matched. And even though $'s end of the line, the white space is expected as a separator coming afterwards. We fix it, we resend the update, and, well, let's see what we have now. Well, we've now moved on to router 2. Router 1. Router 1 doesn't see the update. Okay. Network's not in table. Router 1, we're sending it because we've fixed our outbound filters. Well, let's look on router 1. Do a show run. So, router 1's got neighbor 2222 remote, route map, policy in. Okay, whatever policy is. Policy there has, we're going to match an access list 100 and 101 to match filters coming in, prefixes coming in, and we're also going to do an AS path match also. So, AS path filter 1. So what's AS path filter 1? Right at the bottom it says permit anything originated by AS12. Well, the remote AS is 12, so that looks okay. Show access list 100, permit 10.00.255.255.00, that looks fine. Access list 101, 200.100, whatever, that looks fine. Okay, so that all looks okay because right, we're trying to send network 10 through. So it all looks okay at first glance. So we're confused. Let's try switching on some debugs. So you don't do the debug IP BGP for everything. We set up an access list again. We're picking on network 10 only. Debug IP BGP on the peering using access list 99, just the BGP updates. Switch it on. Try and get router 2 to resend their updates. And then let's have a look and see what the debugs say. Well, it says we've received network 10/8, but it's denied due to the route map. And you go, oh, okay, so the route map's blocking it. Why is the route map blocking it? Let's have another look. The route map. Quick through it, says address list 100, 101, access path 1, permit IP host 10.0.0.0, host 255.255.0.0. Aha, different mask. The reason I skipped through that very, very quickly, saying, yeah, it looks okay, is because that's what people do. I put that very example up in front of a class a few months ago, and they didn't see it either. They had to look at that, looked and look at the slide. And I highlighted and say, well, look, that's the reason. Oh, yeah, we never noticed that. It's just noticing. People seem to be able to swap 255s and zeros and not notice. So if you look at it and you can't see anything wrong, get a colleague in. Don't tell them what the problem is. Just say, can you see something wrong here? I'm trying to let network 10/8 through. And they'll see it in an instant. Okay, so it's just one other thing to watch, these update filters. Okay, so it's the wrong mask. The ACL only allows the /16, whereas you need to allow the /8. So it should be host 255.0.0.0. Okay, in this case. And it's also, okay, this is a Ciscoism. I really dislike people using access lists for filtering prefixes. I mean, as far as I'm concerned, it's obsolete. You should be using prefix lists, which put a nice logical network /mask scenario. But people still insist in using old access lists to try and filter prefixes. And then I use this as an example. This is what will happen to you. You'll end up 3 o'clock in the morning trying to debug something because you don't understand what you're trying to achieve in the access list. Okay? Access list 101 doesn't matter. I mean, it's fine because the condition is odd. That's not the issue. So, summary of all this. If you suspect a filtering problem, become familiar with the router tools. I've shown some of the examples. But a big tip, don't cut and paste. I think I mentioned that already. Cut and paste is probably really bad. But, you know, so many people do it. And not everybody's using Unix boxes for the cutting and pasting either. Windows seems to do amazing things to cutting and pasting. So it's just generally a bad thing to do. Edit your configuration on a TFTP server, TFTP loaded into the router, or whatever other way you have of getting it into the router. Cutting and pasting onto the router console is not a wonderful idea. Watch the regular expressions. In a regular expression, all the characters actually matter. So extra characters, missing characters, white space. I've seen people miss dots and brackets and numbers and so forth in regular expressions, then wonder why things don't work. Some people use things like the IRR toolset to generate configurations. And that can produce wonderful, amazing regular expressions that you look at and go, how did it do this? Is it right? And trying to troubleshoot those, I find, are particularly hard. You've got to trust the tool is doing the right thing. Typos and prefix filters. Watch the CLI. Especially watch the net mask confusion. Because 255s, certainly using old format, can be very easy to confuse with 0. I mean, 255 is very different from 0, but people seem to get, I don't know, white haze in front of the eyes when it comes to putting dots in the right place and so forth. And a lot of 225s appear as well. And that's another one I find is quite amazing. Is you see people do something like 255.255.225 or 255, and then they can't see that either because the 2 morphs into a 5 when they read the text later trying to troubleshoot. Sounds incredible, but I've seen it happen so often. Community problems. Okay, you can get issues with trying to use BGP communities as well. So here's the same example reworked, showing you where communities could cause an issue. Router 2 originates a prefix, network 10, it's in the BGP table, it looks fine, but the community is not set. Okay, if you're trying to announce a prefix and R1's got some community-based filters, or maybe R2's got some outbound-based community filters, well, if the community is not set, you're not going to be able to take advantage of those filters. Okay, so the first thing we do, fix the configuration so that the community does become set. So for example, you could do network 10, route map set community, and the route map sets the community to be 2:2 and 1:50, for example. Then when you do a show IP BGP, you then see the prefix belongs to those two communities. So that's one way of how you might set a community. R2 now advertises the prefix with the community towards R1, but R1 doesn't see the prefix. So what could the issue be? We've fixed all the filters, so what could be wrong? Have they got any community stuff in the way? Look at the router 2 configuration. Well, router 2 says route map set community, prefix list my aggregate out, my aggregate permit network 10, and so forth. That all looks okay. But they've forgotten one thing. Again, different vendor implementations do different things when it comes to sending communities to the neighbors. Cisco IOS does not send communities at all, unless you actually put in the configuration saying neighbor send community. Okay, different people have got different ideas whether this is good or bad, but you need to be aware of it because you've got other equipment, other supplied equipment in your network. They may do different things with communities. They may send communities always by default. So what may be taken for granted in one set of equipment may not be another set of equipment. So you need to be aware of that. So that's where you'd explicitly put particular configuration in to make sure that you get what you want.